right, good afternoon and happy Friday to everyone. Let's round a few windows, pause the previews. How's it going to C. Grover and Paul Cutler and DJ Devin all over on the Discord? Still coffee time, indeed. I've got my cuppa right here. Going iced this afternoon. Well, let's see. This one. Background. Stop you this way. Over the green screen there. Couple of pixels, but it's no biggie. Okay. Oh, no. Oh, just not right. There we go. All right. Good afternoon to everybody. This is the Deep Dive live stream program. My name is Tim. I go by FoamyGuy on GitHub and Discord. This is a weekly live stream program called the Deep Dive, where we are working on things CircuitPython related. Sometimes it will be in the CircuitPython core, sometimes it will be the libraries or the infrastructure or other projects, related in some way to CircuitPython. But that is kind of the common thread that does tie everything together, is the fact that we're always working on something to do with CircuitPython. If you are new to this, if you've not watched this stream before, you don't know what I'm talking about, this website, which is actually circuitpython.org, is the main website for the project, and you can head there if you want to learn some more about it. Basically, though, this is a version of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of those over here on the downloads page. All these devices can run CircuitPython, which means that when you plug them into your computer, they will show up just like a small thumb drive with a couple of megs worth of space. On that thumb drive, there will be a Python code file. You can open that file with a text editor, write Python code into it, and then save it. And when you save it, the device will automatically reset itself and run the latest version of that code. So that's kind of the central concept of CircuitPython, is connecting these devices to your computer. They show up as a thumb drive, and you're able to quickly iterate through different variations of your code by just writing code into that text file and saving it. So like I said, if you do want to learn more, circuitpython.org is a good place to go. Also, encourage you to join us over on the Discord, which is linked down below, adafru.it/discord. There's a CircuitPython dev channel. There's also a help with CircuitPython channel, as well as many other channels that are outside the context of CircuitPython if there is something else that interests you. So head there and check out all of those things. CircuitPython is an open source project. Anybody's allowed to use it on their own devices. Anybody's allowed to port it to their own microcontrollers to add support to whatever microcontroller they want for CircuitPython. You don't have to pay to do this, and the project is all primarily funded by this company, Adafruit. This is their website, adafruit.com. Adafruit is a hardware and software company based out of New York, and they design and manufacture many different PCB devices, many different breakout devices with different things connected to it, as well as some of the microcontrollers themselves. Many of the devices that run CircuitPython are Adafruit designed and manufactured hardware, although lots of them are also third-party. So if you want to help support the CircuitPython project, one of the ways you can do that is just heading over to adafruit.com, purchase some hardware from there, and by doing so, you're helping keep CircuitPython running, because you buy hardware from them. That keeps money going into the Adafruit factory so that they can keep doing their own things, and that's where they are getting the money to pay the folks who are working on CircuitPython. So you are pretty directly helping out if you just head there and purchase yourself some toys. So thanks to everyone who does that, and thanks, of course, to Adafruit for paying myself and all the other folks who work on the project regularly. So today, what I would like to get into is a little bug that I saw pop up in the issues the other day. And I am a bit of a sucker for a good Displayio bug, so I could not resist wanting to jump in and try to understand what's going on with this one. Let's see, missed the stream yesterday and it kind of messed with me. Oh, nope. Yeah, I did stream a bit last night, but I was on my own channel just doing my own thing. I was working on the NeoPixel API a bit last night. Got some more of the animation stuff going. Yeah, so I was on last night, but over on my own channel. Speaking of my own channel, I'm glad you mentioned that actually, because I do want to mention, ordinarily, I will stream also on Saturday mornings. So right now it's Friday afternoon in my time zone. Obviously, wherever you're at, it might be a different time of day. So it's Friday afternoon in my time zone. Typically, I also stream on Saturday mornings. But I will not be streaming tomorrow morning. I've got other plans tomorrow. I'm actually going to a concert, so I'll be in the car headed there at the time that I would ordinarily be streaming. So no stream for Foamy Guy tomorrow, but I should be back at the normal time, 10 a.m. Central Time on Saturdays. Starting next week, I should be back. I will probably hop on at some point, either Sunday or Monday, for the day off, but I have no idea when, and I'm not necessarily gonna like commit to it for certain. It'll just be the kind of thing where one of those days when I sit down to mess with some stuff, I may pop it on. So you deserve it off. Thanks. Yeah. Okay. So yeah, no scheduled one this weekend for the Foamy Guy stream on Saturday. So just keep that in mind if you are looking around tomorrow morning being like, where's the Foamy Guy stream? Not going on for the day, sorry. This is an interesting bug that I saw popped up. So this person has created a bunch of shapes using the display shapes library. And they are saying that when the shapes are hidden equals true, which is a concept for groups and tile grids, as well as vector IO shapes, question mark? I'm not sure about the last one at all. Vector IO shapes, you can put them into a group that's hidden. They might not have a hidden directly on themselves, actually. But in this case, it's not vector IO shapes. In this case, it's Adafruit display shapes, which is the library. This one makes bitmap shapes, essentially, whereas vector IO is a different module inside the core. It's not making bitmaps. So they've basically made a bunch of these shapes, and they've set a bunch of them to be hidden, and it seems that that is causing the device to run really, really slowly. So the first thing we're going to try to do is just replicate this, because we can't really learn too much about it without replicating it. I'm not just going to copy paste the code though, because I don't have the exact same setup that this person does. I don't have the exact same, the exact same display or the exact same main device. So, and then the other thing I will say is the code uses a lot of capital letters for variables and things, and no spaces and things. Syntactically, there's some stuff that's just different from the way that I normally write my code that makes me want to kind of rewrite this and hopefully make our own version of the reproducer rather than having to copy paste this one. It does strike me as very, very odd that hidden true would make it run any slower. Truth be told, I would kind of, like off the top of my head, I would expect hidden true to either have no effect on the speed or make it faster. Those are kind of the two things off the top of my head that I would kind of have expected, but it seems that the real behavior is a third thing, which is that it is actually getting slower. So they tested on a Pico W and a Teensy 4, I believe it said there. Pico W, Teensy 4. I am not going to be testing on either of those. What I have loaded up is a good old trusty Feather TFT. We'll start with that. Obviously, Feather TFT is not the same port as the Raspberry Pi Pico W or the Teensy 4, so if we are unable to recreate it on that port, then we may go try Pico W or something else. This looks different to me for some reason. RSTP, I don't feel like it normally has that. Maybe it updated or something? Neural concerts are a thing again. Yes. Yeah. A lot of shouty text. It is indeed a lot of shouty text. PicoW I can believe, but the TC4 should shred through most stuff. Yeah. Yeah, and I mean, in particular, the specific thing that's going on, the hidden attribute really should not, like, I would not have thought that it made pretty much any difference, truthfully. Okay, this is a copy paste. This is a party parrot web server. This is a learn guide where I submitted a fix for the latest version of HTTP server library. So what we need is just a basic regular old setup. We are going to want to import these things. We're going to want to import board. We're going to want to import Displayio. We're going to go display is equal to board.shouty display. We're going to go main group equals a new group. Might as well from Displayio import. We might not need tile grids. We need a group for sure. Be all we need actually. So let's try that. We make a group. We want to make some shapes. For now, I'm just gonna make one shape just to like make sure it's actually working. In their case, they are doing what? They are making the shape, appending it to a list, and then appending it from the list into the group. Same thing for lines. They did some rectangles this way, then they did some lines this way as well. They append it to the group, the list. Then they're setting hidden true on each one. Then they are appending each one to the group. So one thing is we have a list holding all of our, what I'm just going to call like display objects. They're shapes in this case, rectangles and lines. We have a list holding all of those. We also then have a group holding all of those too, which a group pretty much is a list. So for one thing, we do have kind of duplicated data here in a way, right? We don't, you could just use the group by itself. You don't necessarily need another list. But this is also, I think, a smaller portion of their program. Maybe there's like other reasons why they wanted to have that into a list. Then they go and say display show. The content they're calling refresh because they're setting auto refresh to false. Oh, okay. For one thing, they are calling refresh inside of this loop, which I would expect to probably be pretty slow because that's going to be calling refresh 70 times. I wonder if that's part of it. Is this, like, if you took this refresh back to here so that it happens after the for loop, then it would make all 70 changes refresh once and show all of them. Interesting. Okay, let's draw one thing to start with and just get it so we can see it. And they were saying it took on the order of minutes, I believe, right? Commenting out the hide. One pass of the while loop at the end then takes 0.75 seconds. That's somewhere they had mentioned how long it took. It takes 4 minutes, they say, and it takes 4 minutes. 4 minutes down to less than a second when the things are not hidden. Is our display 240? I forget off the top of my head. 240 by 135 in our case. Setting it to white for now. It's going to be 4 pixels tall. Show the main group. We while true, pass it. All right, there's our first rectangle there, the white one on the top. So the amount of stuff that they have created is how many? $70 rectangles and 150 lines. I have auto refresh currently turned to true though. Can calculating if hidden costs that much time if refresh is called each change? I don't know. I mean, I would not expect so. But I mean, something's going on. Not very confident. Oh yeah, no, I mean, that's nothing to be sorry for. All right. Great. That's running really, really fast. Obviously, we only have one thing. And actually, at this point, we don't even have our one thing because we have not called refresh now. I took auto refresh off. Auto refresh off, so now it doesn't ever actually get refreshed. So then maybe we could go in here and go display.refresh. Still very, very, very fast. And now it does actually draw our white rectangle. Okay, so we're looking for 70 of those and 150 lines. 70. I have 135 pixels only. So if I make 70, they're not actually going to fit on the screen at 4 pixels or even at 2 pixels. Maybe we should do them the other way. For one thing, we actually want this at 0, 0, and then we want, let's say, width. What's 240 over 4 pixels? How much is that? $60. That's not enough. Then it would be 80 for 3 pixels, which should be enough, actually. So we'll go width of 3. We will go height of... let's just say, like, display height over 2. Okay, so now we have a vertical line. And are they changing colors when they're creating them, or doing all the same color? They're doing all the same color when they create them, but they're changing colors inside of the loop here. And then they're calling refresh before they... No, after they change the color, but before they increment. After they change the color on the display object, but before they alter the color for next iteration. They started on white. Around there. So in our case, we'd be doing something like r.fill. Yeah. Okay, now that is changing colors a bunch, going all crazy on us. And it's slower than it was before. I think anecdotally, just looking at these numbers, scroll past us here, but it's still obviously very, very fast. But we also only have one thing. So let's make 70 of those. Range 70 of those. And I'm sure the exact numbers don't matter, but I do want to hit roughly the same amount of like scale, so might as well go with the exact number. I will, let's see, we're going to be doing that. I'm going to skip the list. I guess we'll go back and maybe add the list if it, we don't see the issue occur, then maybe we'll start trying to match their code more, but go, so this is going to be I times 3. That's going to make them 70 across. Gonna append it to there, and then we don't want to be doing R anymore, so instead what we'll do is maybe like for, I'll say display object in main group, display object dot fill equals, and then we'll print the time, refresh, modify the color. Okay. It's looking like it's still going pretty fast to me. Yeah. And then so we have certainly slowed down some. I feel like we're seeing the next seconds digit there come in a bit quicker than we were before, but still obviously very fast. So let's now try r.hidden equals true. See if this is affecting us already yet or not. We're going pretty fast. Seems pretty fast with those. Maybe let's do something like if I every other one hidden. I think that would probably makes kind of a neat effect. Okay. 70 of those, we're not really running into the same thing. Let's keep pushing it closer. In their example, they are adding the lines. They're creating these lines and adding them. But the things that they're changing the color on is only the rectangles, not the lines. We want to make 150 lines. Just gonna comment those for now so that we go back to fully visible. Oh, X0. They've actually just hard-coded, it's always in the exact same place. And the line to them. Okay, way slower. I'll give it that. It's way slower. Now we're getting about 1 refresh every 2 seconds or so. So it is without a doubt way slower. this. Is there detection logic in Displayio yet? A bit like which group at this pixel? Can't remember. Read some GitHub long-term issue. Group at this pixel. I don't think so. As far as I'm aware, there's nothing inside core Displayio where you can give it a pixel coordinate like an XY, and then it will tell you which groups occupy that pixel. I don't think that is a thing that exists that I'm aware of. See, the thing about it is inside the core, the group does not have width or height. It doesn't have size. It has an XY to represent its top left corner. So the XY of main group is in the top left corner up here, but the core does not know the width or the height of that group. It doesn't have those concepts of size. So the core by itself can't really tell you the rectangle that a group occupies. The only thing that you could do is iterate through every child object inside the group and then calculate its bounding box by trying to look at its X and Y and width and height. But groups can go inside of groups, so you have to do this recursively because you need to like go inside of subgroups and find all those things. And then for a thing like line, it's not going to have a height or a width. So your code would also have to calculate based on x0, y0, x1, y1. It would have to calculate the width and height. So to the best of my knowledge, that functionality is not there, where it can tell you like which group occupies a given pixel. And then is it tile grids with XY relative to groups? The tile grids XY is relative to the group that contains it. That part's true, I'm pretty sure. Get tile grid visible on top at this pixel. I don't recall seeing a function like that ever. It could very well be in there, but oh, that's interesting. We got one weird line there. Huh. If we got like a garbage collect in the middle there. Yeah, that function doesn't ring a bell for me, but that does not mean that it doesn't exist for certain. It very well could be there. So yeah, let's save this with that true and see if we slow down considerably more here. Indeed we do. What's fascinating is that we like we went through twice, then we got stuck, and we went through 2 more times. Ah, that is weird. So yeah, we're getting 2 in a row really, really fast. Got another one of those extra vertical lines of a different color there a second ago. We get 2 really, really fast, but then we do have a very, very long pause before we get the next one. What is well, I say very, very long. I mean, it's 14 seconds. Compared to only like about 2 seconds with them visible. Yeah, for one thing, we don't get 2 at a time when they're like this. We only get 1 at a time, and the one that we get is pretty much every 2 seconds. So we go from 1 successful refresh every 2 seconds while they are visible to 2 refreshes every like 14 seconds, and the 2 of them come pow pow rapid fire, but then you have another 14 seconds. Interesting. Let's tinker with this a bit. What if we had line group is equal to another different group, and then we said we wanted to put these in the line group? And then we will, of course, want to go main group dot append the line group. That's going to put it before all the rectangles. I don't know that it matters, but I think I want it after the rectangles, so I'm going to do that. That's going to then fill it with lines. We're back to hidden, not true. So I would assume this is the same here. We should get the same thing. So about once every 2 seconds. Line group. Right. Because now we have a group inside there. If is instance or has adder. Let's go has adder. Display object. Fill. Diagonal magic. The clarification. Yeah, for sure. Okay. Yeah, so we do get basically the same thing here. One refresh every 2 seconds, which is what I expected because we haven't. The only thing we changed is just put that in a different group. Not expecting that to make any difference. Now, what I am curious though, and I do not have a good guess for, is when we say line group dot hidden like this, is that going to slow way down again? Yes. And we get back to our 2 refreshes. Very interesting. Okay. Oh, while it's in that 14-second wait, you can't actually control C very effectively either. One thing I will say, I mean, it will depend, I guess, on what you are trying to do. One thing I will say, though, so far we're drawing basic shapes, and we're using the Adafruit Shapes library, which means that we're ending up with a bitmap for every single one of our shapes. A slightly different approach could be make one bitmap that's the exact size of the screen, and then use bitmap tools in order to draw things into that bitmap. The difference would be we don't end up having individual objects that represent every one of our shapes, but visually we could draw all the same stuff by putting all of it inside one bitmap using bitmap tools. I think there's a function called maybe draw rect or something, maybe fill rect. And then I'm pretty sure there's a line function as well inside bitmap tools. So like visually, you could achieve the same thing as this by doing that, and I suspect you would not run into the same kind of issue. However, you also don't have objects to call hidden on, so like you can't hide and unhide things that you draw this way. Yeah, there's a draw line, and then there's a draw polygon, which you could do for a rectangle. Yeah. Oh, fill region is pretty much draw rectangle, I think, as well, actually. That's one thing to consider as well, but for all I know, maybe they chose this example just to illustrate this specific thing with hidden, which again, like I said, you would not be able to do with bitmap tools since you wouldn't have individual objects. Let's try every other one here. Do we slow down to 7 seconds if we do this? Okay, so we got 2 about 1 second apart. Then we're in a big wait. Actually, it's feeling like it's longer than 14 seconds. Okay, maybe we found one of those full minute ones here. Were they setting all of them? Yeah. Commenting out this line solves the lag issue. Huh. Okay. Oh yeah, we've made it last way, way longer now. Oh, yeah, and because it's stuck, I can't control C either. Oh, there it goes. So I was trying to see what it would do if I dropped it down to only 2. And then made one of them hidden. That seems like it didn't really have an adverse effect on the speed. But definitely relies on there being a lot. This time we kept the 2 quick hits and then delay, but obviously our delay is much less. Or like 1 second, which is 1/10 of about what we were getting before at 150. So that feels linear, pretty close, I think. Guesstimation wise. We had 150 there, we were getting about 14 seconds. We have 10 here now, we're getting about 1 second. Very unscientifically measured. And again, same thing here. If we don't make them hidden, then we go back to fast. Okay. Let's test a few more things before we jump into the core. I'm gonna turn auto refresh off. I am gonna not refresh here. I'm gonna put this back to 150. So we're getting kind of like weirder looking stuff here because it's refreshing at different intervals when more or less stuff has happened. Interesting effect. Let's make it a bit difficult to follow like when anything is happening. We are super fast if we don't call refresh. So now we are back to about our 1 refresh for 2 seconds. And you know, one thing we still have yet to do, so I'm doing my refresh out here currently. What if we did it in here, which is more like how the other one was? How's it going, Saint, over on YouTube? Evening. Display.refresh that right there. What this does. About one, it's still about 1 every 2 seconds. It's not making that big of a difference. You know what the name for the board is called? I'm not sure if it's called perforated board, 5mm holes, or proto board. Been searching and searching, you came across my channel. I have heard of a thing called proto board. I have also heard of a thing called perf board. Truth be told, I'm probably not the best person to know the like specific actual definition of either of them. This is at least what Adafruit sells as universal perf board. I don't know the measurements, if that's 5mm or what. You'd have to look a little more into here. These are like proto breadboards, so these have breadboard sizing, but it's actually a PCB instead of a plastic thing. That's about all I know about it, truthfully. I don't really know the actual specific definitions. So this one is very slow. We are back to another very, very slow one, because we have not even printed the first one of these yet. Okay. So we know that, and this does feel slower even than the alternative like this. Okay, well, but also we're even more stuck now because it's running that first one. We're stuck in it. We can't control C or anything. Like a flexible panel. Thanks for your help. Appreciate it. Oh, interesting. Yeah, I've never seen flexible board. That sounds difficult because if you solder to it, the solder joints will not be flexible. So then if you flex the board afterwards, I would assume the solder would pop off. Sorry, I missed a couple of these. I use round direct on Featherwing. Hide it. Quick and complete snippets. Show the idea in error.com. Help me with the perf board. Oh, sorry, that was probably loud. My bad. Perf board is made to be easily cut into shapes. Oh, okay. Proto board is harder with copper fill. Can't really cut them. Key. There's a link there on the Discord if you're interested. Over on YouTube, there's a link in here for DigiKey for searching up some of that stuff. It's like proto board is like PCB, breadboard, perf board doesn't have holes connected. Oh, that's a good one. Yeah, perf board, like each hole is independent. You kind of have to run those wires to make your connections, whereas the proto board, some of them they'll have like rows of pins connected on the copper. Wow, there we finally got one, but it was 68 seconds. Over a minute. Not the 4 minutes that the OP from the user. Of course, I also only have half of them hidden. Okay. I think we have seen enough to get started. So for one thing, I have got a modified version of this from when I was working on trying to do SD card initialization. So what I'm just going to do is throw that onto a branch. Commit it. Push it, but it doesn't matter. Truth be told, I probably will not be picking this one back up, the SD card. Maybe one of these days, but for the actual project that I was intending to use it in, I have come around to not wanting it to be initialized in the core anymore. I am making good progress on that project as well. At some point, I will try to distill the parts of it that I can share out and publish a project based on it. But the specific one that it's actually doing is not something I can publish. But it turned out that I don't want the SD card initialized inside the core because I want to be able to initialize it, read the file off of it, update the display, and then unmount it so that way if we reset or if anything else happens, we don't have it initialized. That way we won't get corrupt files and stuff. Whereas if it's initialized inside the core, then it's like always initialized and mounted. If anything goes wrong, it could be like halfway through writing a file or something like that, which we wouldn't want. So we want to go inside of display refresh. I'll start in shared bindings. My guess is we're going to want to be going into shared module probably, but look at where. Boolean true. Auto refresh. So there are also these things, which I don't actually know the real way to use these. It's false immediately. That sounds like it might be helpful. Target frames per second. Frames per second. Per second. Stuck in that last one. I've never actually worked out precisely how these the target frames and the minimum frame stuff works. Does not seem like that's having really any effect on it though, because we again got our first couple. This time it's 3 instead of 2, which is interesting, but we got our first couple and then still get stuck in one that's just taking forever. Okay. We're in here and we are calling to common HAL Displayio display refresh. So we want to go into there. Why does that highlight? Highlighted? That's annoying. Get this. It's probably this thing. Let's see. Okay, we want to find that. That one's going to be over in shared module. That's going to be where the actual business happens. This stuff here is all validation of the argument things. I strongly suspect nothing in there is what's slowing us. Double as a needlepoint canvas. Can't set your GPU to do 5,000 FPS. Just let it try. Yeah. I mean, like, conceptually, I get what it is saying, but, like, I've put different numbers in there and not really figured out what the different behavior that's resulting from those numbers is. I've tried putting different numbers in there and figuring out what it does differently and not, like, walked away really understanding anything at all that it does. I get, as far as I can tell, I get what it says it does. I just don't see, like, functionally, doesn't seem to me like it does that or really much of anything in the times that I have tried to use it, but most likely I assume I'm passing the wrong arguments, essentially, just not using it right. Okay, so common HAL display refresh is here. So first thing it says, if not self auto refresh, if and not first manual refresh, and target millisecond frames per second is not equal to a large hex number. Guessing is that max int. I don't know what that is for sure, but current time equals supervisor ticks that. Current millisecond since real refresh, current time minus last refresh time. Test to see if the real time is below our minimum. So here's, I mean, this is the logic inside those things. Below, so this one will raise an error, actually. Interesting. Current millisecond since refresh greater than maximum per real frame below minimum frame rate. So will this raise an exception if we have a minimum here? We did eventually get these, and it is 30. Well, they're different, actually. Well, we got 147 and then 149. Interesting. We got 4 within the span of 2 seconds, and the same thing up here. If we go minimum, if we put that as 2, is it going to raise exceptions on us? Okay, we do have to wait because now it's stuck in there. Switch back to here, following through this. However, if your MCPU is capable of hitting the target, then it'll attempt to do that FPS. I've done it overclocked the TFT display too. A little wiggle room on the M4. But yeah, M0s can't do much of anything on displays. For SAMD21s, I mean M0. They call the Pico an M0 as well, or M0 Plus or something. I think I've seen it, which like Pico is a different class than the MD21s in my mind. Okay, so that one is looking like it should raise. I don't know, we didn't actually get an error raised. And it's definitely taking longer than 2 seconds, right? Like we told it here, but we told it minimum frames per second, and then we told it 2. So that's actually 1 frame per 1 frame per 1 second. Yeah, no, minimum frames per second. No, we told it 2, so that's 1 frame per half second. And it's definitely way slower than that, and it's not raising so far. So yeah, I don't get what that. This is my ignorance, I'm sure, though, not like don't know how it works. A bus limit. Goes back off. Those were not in the original reproducer. Since I already don't understand them, I don't want to bring those into the mix. But we can see here it would raise an exception in some case, maybe. If milliseconds since last call, so that's current time minus last refresh call. Last refresh call then gets updated to current time. Got set here. Returns false, so there's the skipping in order to catch up. That's part of the logic of those two numbers, where this should return false. I'm gonna leave that alone for now. Remaining time, we're still calculating stuff based on this. We're ahead of time, so wait until we align with the frame rate. I'm going to guess. Oh man. Go to expressive. We want to activate, which is called what? Dot space dot slash ESP. It's called export. That's what it is. Export. Oh, export. Or activate. Now we can make. Okay. First of all, I don't know if I did this right, but we'll find out. And then I don't really expect to see this print anything. Mostly I'm confirming my hypothesis here, which is going to be that I don't think this is going to print anything. while we are in these long wait periods here. Basically, I don't think that we are inside of this when we are waiting, but if we are, this will tell us, because that will spam. While that's building, we can continue on with the logic. So that's like a while loop that's just waiting. Then it says first manual refresh equals false. Then it says refresh display, which is this. Fix a display object. Nope. Called object is not a function or function. Printf. I did it wrong. I wish there was a good resource to go to look at this. I cannot, for whatever reason, this always eludes me. The way to print. It's such a basic thing, but I just do not remember. It grep mp. Is it not really? I thought it was printf. Mp not. It's not printf. It is and different thing though. Oh boy. I think I got it right actually, but what? We don't have a cycle. Bros. Not touched by. Should have done this before I started the stream. I forgot. I updated the main branch, but I forgot to fetch submodules. My guess is that my local copy of Microlab was different than the one that's in the main repo now. Like, I guess it probably got updated. Hopefully that's what's causing those errors. Scorpio. Is it dependent on display hertz? You get a little more FPS. Scorpio with PO to improve FPS for NeoPixels. On PCs or Raspberry Pis. Yeah. Yeah. Oh, that's definitely true. I just think we shouldn't be hitting the limit by making our thing hidden. It shouldn't slow down as much as it does from us making a thing hidden. Realistically, hidden should make less work, not more. I would have thought. Might be like looping through the pixels for some reason. Okay, now we got all that updated. Alright, fingers crossed. I should be doing clean also, maybe. Pretty please. I should have done clean a while ago, honestly. That should have been one of the first things I tried. Advanced user SU, let's use it 20 for most projects. Oh yeah. Yeah, Displayio is good for like, I mean, honestly, like if you're not trying to do motion, if you're not trying to have a thing move necessarily, if you're just trying to pull data from whatever, any kind of system ever, and put it on the screen and update it every few minutes or a few seconds or whatever, Displayio is more than adequate for that. But if you're trying to have like real-time 3D animation spinning a 3D rendered sphere or something like, then it's a bit much. Or if you're trying to animate smoothly across a screen, like you could get by with one thing maybe animating pretty smooth, but you start adding more than one thing animating, or the thing that you're animating is too big, and then you do start slowing down a fair chunk. But this is even beyond what I have seen. Like, Displayio is relatively slow, especially if you're changing an object that's big. But this is even slower than I expect. You know what would be interesting to see is if we made these lines either straight vertical or straight horizontal, if it slows down the same amount. Because inside of here, line, I'm pretty sure it's making a bitmap. And so in our case, it's going from 0, 0 to 100, 100, which means our bitmap actually has to be 100 by 100. So we have 10,000 pixels in memory in order to only draw on the hypotenuse of the half of that thing. I don't know, that's not 100, but it's like 100 and something. Okay, this did build. Let's run this. Vector IO. Yeah, it would be interesting to try that as well. I'm curious if Vector IO, like, how that would interact with this little quirk that we have found here. Like, if we changed our rectangles and our lines to Vector IO, I wonder if we would still slow down the same rate, or if it would be different or not at all. Gotta tell it where. But even if it doesn't slow down with Vector IO, I think we want to still chase this. So I'm not going to go and chase the Vector IO part of it just yet, because even if it turns out that Vector IO is fast, I think like this feels broken. This feels like there's something that we should hopefully be able to fix internally to make this faster. Even if there is a better way to do it, it'll be good, I think, to make this way work as good as it can. Which, yeah, maybe it turns out that it is as good as it can. In which case, that's as good as it can, then Vector IO would be a good potential workaround to try to make it faster, but it's at least worth a good deep dive, pardon the pun, to take a look around and see if we can't figure out where we're losing the time. Okay, so as expected, this did not, we're not seeing this print, so we're not stuck inside of there. Which I thought was a long shot, but it's worth a quick test. So we are then going inside of refresh display. Here it says, if not, Displayio, display core start refresh. Refresh on this bus is already in progress. Try the next display. Interesting. I wonder how simply returning from here would make it try the next display, but we're not worried about multi-displays right now, so I'm not gonna think too much about that. We have Displayio area, current area equals get refresh areas, while current area is null, refresh area. So we're calling refresh area on each area. Then we're saying current area equals area.next. So we're looping over areas. With some kind of linked list type thing here. Get refresh areas. And then we're able to like get one out of it here, pass it into this, and then we update this with the next one. So it's like that node is pointing to the next one, we're grabbing that and pointing it to here. And then it says Displayio core finish refresh. Let's add some prints to here. I should not have deleted that print. Also worth noting, I keep saying that I can't remember this, but I have actually gotten it correct, I think, the last 2 times that I tried, even when I didn't think I had it correct. We're going to take that there. I'm going to say here, after Git refresh areas. I'd be curious to see how many refresh areas there are as well. Like, is every object a refresh area? And who's responsible for making it so hidden things don't get an area? That's probably deeper inside here, I'm guessing. So we'll do after this, we'll do another one after these. So after all of these, after while loop. I don't have semicolons on any of these. And then we'll do one more after this to see after the finish. After finish, refresh. Okay, make the build. I gotta run to the restroom, so I'll be RB. Okay, got a build, bootloader. Missed it. Fast. Let's finish. Got a semicolon. That was from before. Well, it must be because we got a build. It must have been from. Getting every 15 minutes from 7 APIs. Nice. Oh, works pretty well. Shut off display recently with. Okay. And running. So the period where we get stuck is after get refresh areas and before after the while loop. So we're getting stuck in that while loop in here. This is where our time black hole is at. I don't think that's the right way. Maybe it'll work anyway. I don't know if you can do that. I am really bad about semicolons. If I thought I was looking at Arduino project. That's not the right way to print a number. You need to do this thing, then pass it after a comma. But I don't know, is %02x, is that what we want? %d, I'm pretty sure that's actually what. At line D, yeah, maybe D for int, I think. %d comma I, yeah, thank you. Get it, Mr. Goodbits. Oh, I did not go to bootloader first. Copy over. Not sure who the author of the project is, so they might want to get in touch with Jose W. Try to get a factory out. Yeah, well, I think it depends a little bit if the, like, I don't know if the sample, I suspect the sample they submitted is not like their literal project. I think they made a reproducer. Huh. It went really fast up until about 70 or so. Now it is much slower. But fresh areas. We have 150 plus 70. We have 220 objects. So I think we currently still have the line group. Is that true? Buffer slowdown? Not sure. That's a little bit too coincidental, I think, that we exactly at 69, which were 0 based, so number 70. Also, the fast one stopped there for some reason. Did not go to 220 like I had expected either. I don't know where it got the number from. It's pretty random. 144? But it definitely slows way down right at number 70, which we have 70 rectangles. So I presume it slows down after those. If we make these rectangles also, yeah, that's a bit too coincidental. I'm curious if it's just lines. Are lines just slow? But I also am curious if we go back and put these in main group instead. Let's do that first. But then I'm gonna try making rectangles here, 150 new rectangles, and see if we still go slow. Okay, we are in the, we can't reset while it's doing its thing, so I'm going to push the reset button. Ordinarily, I hesitate to do because then it disconnects and reconnects from my computer. I think there's like a off chance that eventually sometimes my computer can crash from that. Fingers crossed, knock on wood. Hopefully that's not going to be happening. Okay, we still slow right down at 70. So this makes me think that being inside of a different group does not matter. Now we're back in the same group, but it does seem that lines are slow. So far right now it's looking like lines are slow. So let's see if that's the case by changing these to rects. Rects. We'll just do R again. Let's make another set of these ones. And it's making them all just layered right on top of each other, so I'm just going to do the same thing. I'm going to say x equals 0. I'm going to say y equals... Let's just go down below the other one by a little bit. Display.height over 2, but then just plus, like, I don't know, 5 or something? 6 maybe? Let's just do that. Width. Let's go, I don't know, 100 maybe? Height, 6. That. Okay, one thing too, though, this would be changing... Does line have fill? I don't actually know if... Well, it's not changing colors, so it must not. Line extends polygon. Polygon extends tile grid. Rect extends tile grid. Points. The line is just making a special polygon. It's just passing those 2 points right back in. We're giving it x0, y0, x1, y1. It's just taking those 2 points, passing them right into polygon. Let's calculate the size. Does not seem to have fill, though. So those fills would not be doing anything. I'm gonna go back to using the line group, actually. So here I'm gonna say line group dot append R, even though it's not a line anymore, it's a rect. So yeah, line group, not do hidden true. That's going to be looping over main group, so only the rects that are in the main group will be having fill. Line group is technically inside main group, but it won't have a fill, and this is not recursive, so it's not going to go inside of it. Yeah, line is just slow for some reason. Well, okay, hold on though, right? Hold on. R.hidden. I will say too, like this would go way faster if we weren't printing either. Like if we went back and took out all these print statements again, we would iterate through this even faster. But this is way faster than what we were seeing with the lines. So yeah, something about the lines just slows the refresh way down. Honestly, I'm assuming it probably doesn't even matter if they're hidden or not. They seem to slow down worse when it's hidden. But it probably slows down some even when they're not hidden compared to like what we're seeing here. Very interesting. Okay, next thing I want to try is what if our line was not diagonal? I think if our line is not diagonal, it might actually go faster. Okay, let's get this back to slow. Okay, there we go. We get all the way up to the lines and then we slow way down. Interestingly, I mean, these seem to be taking about the same amount of time as each other. Is a little bit weird because like hidden seems to slow it down, but we only hid half of them, so I would kind of expect like one fast one and then one slow one and then one fast one and one slow one, but not actually seeing that pattern either. Okay, what if we go from 100, 0, 100 to 100, 100. So we're making a fully horizontal line instead of a diagonal. Minus horizontal or vertical, it could just use pixel fill instead. Yeah, I mean, there's a lot of things could use other things instead, for sure. Definitely for sure there's other ways it could work instead. What I'm trying to get at though is like what is the thing that's causing it? That is way faster again. So definitely using that diagonal line is making it way worse than if it's a horizontal line. And then I would guess we go, let's say like 0, 0, 0, 100. So vertical line, assuming we stay fast again. Yeah. It's definitely specifically that diagonal line. I can't say as though I'm that surprised by, because that diagonal line is about the least efficient shape that you can get, right? Because it has to build an entire bitmap that's a rectangle. It has to build that 100 by 100 rectangle. And then the only thing I could think of is we must be iterating through those pixels in there, I guess. Seems like we must be iterating those pixels. That's kind of interesting. Oh, I see. We're in the, I see. Right. We're in the REPL here, but I have, because I've added all these prints and the display is now refreshing with auto refresh because we're in the REPL. This is now happening. Okay. I wish I could like stop it for, I could like, no. I can't even see what I'm doing. I don't know. It's not worth messing with. It's happening for now. So refresh area. Let's keep chasing it. Cannot find. That's a good start. What is this? Refresh area. Okay, there we go. I don't know why it couldn't find it. It's in the same file, but whatever. Buffer size, 100. know what that 32 T's. Don't know what that means really. Area clipped. So create a Displayio area called clipped. Displayio area is an interesting one. I'm pretty sure this is a core only concept. I don't think this concept shows up on the Python side. Clip the area to the display by overlapping the areas. If there's no overlap, then we're done. Fine. Control click. Go in here. Say not clip areas, no overlap, done. Hypothesis here is that this is not where we are losing time. Basically, I'm expecting to not see this get printed, I'm thinking. I don't know what the clipped areas is doing, truthfully. Rows per buffer, pixels per word, pixels per buffer. We could print those out, maybe. Subrectangles equals 1. Okay. We are currently on the vertical. Let's change it back to the diagonal. Okay. Yeah, we don't see those getting printed. We're not having that, whatever that condition is, we're not finding it. We're not getting it, having it. Not going in here, we're not printing this. That's not factoring into our time at all. I'm gonna print these out. Goes per buffer. D. Pixels per word. Pixels per word. I have no idea what these values are. Pixels per word. I don't know what kind of word it's talking about. Oops. Pixels per buffer. See if those are big. Maybe these are like way smaller for rectangles and way bigger for lines or something. For performance and memory. Over lines. Line is horizontal or vertical. It could use pixel fill instead. Only with lines that aren't horizontal or vertical that a polygon would be necessary. Yeah, that's true. Yeah, you could do for either horizontal or vertical, you could use rectangle instead, essentially, instead of line. Although I think it's not by virtue of being a line object that's making it slow. It's by virtue of being a line object and being big, like in the diagonal, which is making it a lot more pixels. I'm assuming the number of pixels is factoring into it. Bootloader. Because yeah, we did the horizontal and the vertical lines, and those went way fast. So those are still line objects. So we know it's not just merely line objects are slow. It is specifically those line objects that are using that diagonal in which case they're kind of like the least efficient of the line objects since they have to have a full rectangle, but then they're only filling in, 1 pixel all the way per row or whatever across the diagonal there. Okay, now those don't seem that different. In fact, there were more pixels per buffer for the rectangles at 402 than for the lines that are 202. The other two numbers appear to be the exact same, in my eye, just at a quick glance. 202 changes, but it gets smaller. So that's interesting. I'm going to comment this one for now. Maybe we'll turn that back on, but I'm not sure. So then after that, we say sub-rectangles is a uint number. I think this is a number, equals 1. SH1107 boundary. So we're not doing that. That's going to be false for us, I'm pretty sure. Let's see, the bird. Bird the word? It's the bird. The bird is the word. Birdie birdie. It's a combination of techniques for speeding up real-time digitizer, improving from 5 to 5+ frames per second to 2.5 second. Steppy thing there. Lab to squeeze out another 10 to 20%. I'm pretty sure we're not going to be in there. We're going to go in here and it's saying what? Displayio area size clipped greater than buffer size times pixels per word. So that's going to be pretty big, right? Buffer size. No, we don't know buffer. Well, buffer size actually is up here. So that's 128 times pixels per word, which was the last one. Nope. Pixels per word was here. So that was a very big number. 128 times that very big number. If display IO area size clipped greater than, I don't know what that means. Another bird? Bird's the word? So I'm going to print these values out. Oh. Done this wrong. I've done this very wrong. Hold up. We put %Ds here and then we never passed anything. So those really big numbers probably were wrong. I don't even, where did those values even come from? I don't even know what it was printing. Or just like random memory, I guess. I don't even know what that was. That's weird. Okay, I'm surprised that compiled, honestly. Okay, I gotta BRB again. Discovered the power of microlab. A lot of stuff with that microlab, that's definitely true. A lot of number crunching goodness. Okay, now we got some real numbers here. Much smaller. And start to get maybe a hint here, because we actually do have a lot more now pixels per buffer. We have more rows per buffer. We have the same pixels per word, but we have 10,000 more pixels per buffer. Okay. Maybe the overall size is important. Maybe the type of object is not important, but the overall size. So, because I changed this to rectangles and we sped back up, but the rectangles I changed it to were smaller. What if we did this as 100 by 100, which is the same as what our line is ending up? It's going to draw over the top of our other things. Does this go slow as... Oh, you were down there, buddy? Okay. Stuck in the old one. I'm going to reset. It's still quite a bit faster. It does have 10,000 pixels per buffer, so we still have that 100 pixels times 100 pixels. And it's slower than the other rectangles. It's slower than the smaller rectangles, but it is still way faster than the lines. Right. Wish we had a way to not do this in the REPL. Could release displays? That doesn't seem like the best. I feel like we might have just stumbled onto something though, because we're not seeing any 10,000s here. And to my eye, I'm seeing a lot of 67s here. I'm not sure if it's counting up. Oh, I can stop it if I scroll, actually. We're stopping. We're stopping at 69. We're not doing the other ones. So when it's a rectangle, oh, what did I do here? Hidden equals true. I don't know what I was doing there. When it's a rectangle and it's not hidden, when it's visible, we don't have... Now we reached the end of the buffer, so now it just wants to scroll on. We don't iterate through it. We stop there. We don't iterate through the visible rectangles. But when they're hidden, we do. Because here we're going on into the 70s. So I will say already that feels kind of wrong to me. Because, so what that means is that when the rectangles are hidden, they are getting returned into here as part of get refresh areas. But when they're visible, they're not. Probably because they're not changing. That would be my guess, is because they're not changing. If we were to make another loop inside of there and change the color of those other rectangles also, then I think they would be part of this loop, because then they would be changing. But when they're visible and they don't change, they don't get looped, they don't get iterated over here. So that's one key difference that definitely is part of our slowdown, is the fact, and it doesn't make any sense to me, because if they are hidden, we should be able to skip iterating them, not the vice versa. It seems like we're getting the opposite. It seems like when they are hidden, we are iterating over them, refreshing them, but when they are visible, we're not. So it feels like something has marked them as dirty, which is like, tells the system that it needs to refresh. Can a rectangle be on a diagonal? It cannot. Nope, has to be squared up on the 90s there for a rectangle. Rectangle can use fill instead of polygon. Yeah, again, there's definitely different ways to do this other than polygon and rectangle, but what we're trying to look specifically into those things, because they seem slower than they should be. So yes, there are ways I think you could speed it up by doing it differently, but also we want to understand why it's going slow when we do it this way. And so it's worth continuing to do it this way, even though we know that we could probably change it to a different way and speed it up. That's very weird. The fact that we iterate over them when they are hidden, that's definitely feeling like part of the puzzle here. So let's keep looking at our logic. Well, you know what? Actually, let's go look at, see, I mean, the crux here is they're getting returned by this. Let's look in here. Where did this come from? Static const area. Strangely, we have an ampersand at the beginning of the function name, which I don't quite understand, but that's... So this is saying if self.core.full refresh, then self.core.area.next equals null. Then it returns area. Else, if core.currentGroup is not null, then return get refresh areas. So I would assume that we are in this one. I don't know what core.full refresh is. I'm assuming that we don't come into here, though. When I say assuming, I mean hypothesizing. It probably would be a better term. Maybe it's because rectangle will never have any transparent pixels, so there's no need to check what's below it. Yeah. Yeah. It could. Good thought. Yeah, with the line, we have to draw stuff underneath, basically. Rectangle, we don't, because with the rectangle, it's always all or none. It's still weird to me though that we get those extra iterations. It feels like we should somehow be skipping the iterations of the hidden ones. Like if they're hidden, we shouldn't really have any kind of refreshing or anything to do. We should be able to just skip it altogether, I think. That does make sense, yeah. When there's and the line polygon in this case, the line, it's a 100 by 100 bitmap, and then it will have mostly pixels that have been on the palette turned to make transparent. But then that one diagonal in the middle, in our case, would be the pixels that stayed opaque. Yeah, see, make transparent here. So most of the pixels in our line polygon are transparent, whereas in our rect, none of those pixels are actually transparent. But I do still think, like, we should be able to skip it if it's hidden. It still strikes me as awkward that when they are hidden, they get iterated and refreshed, but when they are not hidden, they don't get iterated. What if we go back to like this? Apparently we don't have a way to make it go faster. We just wait. Okay, there we go. So yeah, so here they're now visible, and so now we're not iterating over them. Presumably because they're not changing. I would guess like the first time it probably did iterate over them, but then after that it stopped since we aren't changing them. But what if we made the pixels transparent? How do we get the palette off of this? We just say like r.palette or something like that. Maybe it's a pivot variable. Palette, look in here in palette. Underscore palette. So the palette has 2 colors in it. We are setting pixels to index of 1. Fill is none. Why would you use fill none? I don't know why you would ever use fill none. What if we said r.palette make transparent 1? Does this mean that they now get iterated? Okay, well, for one thing, it's visible. Maybe we need to do go in 20, 40, 50. Nope. Not currently iterating, so that actually did not change the behavior at all. That one did. So 0, I guess, is the 0, I guess, is the actual color. But we also still are not iterating over them. Interesting. How do we iterate over things when they are hidden? And the line goes so much slower than the rectangle. I think that's probably more like what Shipu said, is because the line has to care way more about its transparency. It has to get the stuff underneath it or whatever. If rect is using fill, not sure you could specify a rect not to have a fill or to have a transparent center. Oh, transparent center. I forgot the fact that rect, it can do an outline as well, which is exactly why you would want to potentially set it to fill none, if you want the outline but no infill. Yeah, good call on that. Forgot that it does outlines. But yeah, that's almost certainly that's the case, I think. Full refresh true. Fine. Save that, semicolon, save that, build. We are getting pretty close to time for the evening. I don't necessarily have an exact hard cutoff, although I am getting a little hungry, so I'll probably be not sticking around for too long. Ordinarily, this would be the part of the show where I would say that you could join me tomorrow morning, Saturday at 10 a.m. Central Time, and I would be back streaming again. But like I mentioned at the top of the show, there will be no Saturday morning stream tomorrow. So next Saturday morning, not tomorrow, but 8 days away, Saturday morning, then I will be streaming at 10 a.m. Central, but not tomorrow. Okay. Probably what I'll do is when I wrap it up here, I will put a comment onto that issue with my findings, which so far I would say the findings are we reproduced it for one, different code. We found out that lines specifically are slower than rects. And we found out that when you set hidden true, they are still getting iterated over inside of the place that's using this, inside of this refresh area. Where refresh area is getting called from. Refresh display. They get iterated over inside this while loop inside of refresh display when they are hidden, but they do not when they are visible. Okay, and we are not seeing that new output, that full refresh, not having that. We are iterating over all of them, but they are rectangles, so they are faster than lines. Rect with a fill color of none is transparent. Yeah. Yep. Thank you. I was for a minute I was like, why would you ever do that instead of just not making the rectangle? But I forgot about the outlines. You can have outlines on them. I was not thinking of, but that would make perfect sense. If you want the outline only, then you would set the fill to none, and then you would set the outline to whatever color you want. Which we haven't even really messed with outlines. I don't know how the outline works on Polygon though. I don't think you can do an outline for Polygon, but I'm not actually sure. Wait, where did I add that other print? Area? Lost in here. Okay, in here. Get refresh areas. That's where we went. Okay, so we're not getting that. Instead, we must be going in here, or altogether, like none of those are being true. Let's add this one. See if that prints every time. So core current group not null. Whoops. Core current group not null, shouty. Then I would guess that we do see this one printed. If we don't see this, then we know that neither of those are true, and instead we're just returning null, but I don't think that's the case, probably. Twitter while it's building. Oh, you know what? I actually covered up the chat a while ago. YouTube chat. What's in there? Not either. But are we looping? So this only gets called once, and then we're just immediately spamming inside that while loop, actually. We need to probably turn that off. Just join, what are we doing? How's it going? First of all, Steve Ewart, I will say, I hate to be the bearer of bad news, but I am going to be wrapping it up pretty soon here, so unfortunately you joined pretty quick right before we're getting ready to go. That being said, obviously the VOD's there, so you can still check out the rest of what we worked on. And with all of that aside, what we are working on is we're hunting for a bug inside Displayio, which is the CircuitPython. I don't know your level of familiarity with the project or not, but Displayio is one way to draw in displays in CircuitPython. What a person has submitted as an issue is that with Displayio, when you have a bunch of line objects that are hidden, the display takes a very long time to refresh. And if you make those line objects visible instead of hidden, then the display refreshes much faster. And that's weird, and we're trying to figure out why it's doing that, and then hopefully once we understand why it's doing that, we will also be able to make it not do that, because it should not, probably. It should be able to go fast if, should be able to go fast, especially, like, the more things are hidden, then that means the less things that need to be drawn. So, like, you know, we would expect it to go faster, I think, rather than slower. I would expect it to go faster rather than slower. That being said, like, I know for a fact that I don't have the full mental picture of Displayio yet. That being said, I do understand a lot of it. I would guess that amongst people who did not work on it initially in the core, I probably have about the deepest level of understanding of anyone who did not actually work on it at this point in the core. I don't really see too many other people mucking about with Displayio inside the core all that often. K-Match occasionally pops up, does some work in there, gave us a lot of stuff in bitmap tools as well. Jeff does a bit from time to time, but I think Jeff was probably working on it when it was originally created. Shipu done some updates in the core with like the pew pew stuff as well. I think the Shipu's the one that made groups behave like lists. That was in the core Displayio not too long ago. I mean, I say not too long ago, maybe a year or two at this point, but getting a lot of these. I guess we need to turn that off too, probably. That must be inside the loop then. Yeah, for sure. Oh. Sizes. Uh-oh. Killed this one. Oh. Okay, yeah. Indeed, we do get that, it looks like, every time. Or current group not equals null. Figure out back to where that was now. It's here, or current group not equals null. So we are doing this, therefore we are then going inside, calling this on the current group. get refresh areas of the current group, core.current group. I don't know what core.current group represents either necessarily. It's going inside of here, which does not have a definition in this file. Not sure where that comes from. Displayio group, get refresh areas. The inside group, I guess. Yeah, 440 inside group. I could click that. Get refresh areas. Inside of here, we say if self.item removed, then self.dirty area equals next. No, dot next equals tail. Tail equals self.dirty area. I don't know. This looks more like some more linked list stuff going on there, but I'm not entirely sure. I self members length, that's going to be looping over all the members inside the group. So for one thing, I would say here, before we go inside of here, we should probably be checking hidden. If hidden is true, then just don't do any of this for one thing, I think, right? Get refresh areas. So what does it basically say when it does go in here? So if vector IO is enabled on the build, then it's gonna say like try to get the like we're looping over the current like the items inside the group. The display objects is what I was calling them before, although this calls them members. So we're looping over those display objects. Each one of those display objects could be one of three things. It could either be a vector IO shape, which we're not messing with in this example, so none of ours are that. It could be a group, so you can nest one group inside of another group, or it can be a tile grid. Those are the only three things that you can put inside of a group. So while we're looping over all the things here, it's going to be one of those three things. And now, of course, you can have subclasses, right? Like we're putting a line object, and the line object extends the polygon object, and the polygon object extends the tile grid. So like not directly the tile grid, but eventually if you follow up the chain, then you get to the tile grid. So here it's going basically figuring out which type of object it is. If it's a vector IO object, we do this one. If it's a tile grid object, we do this one. If it's a group object, then we do this one. And in our case, we mostly have tile grid objects. So we are mostly doing this one. And I would guess then that that is inside of tile grid here. Indeed. And here is finally where it looks like we might be doing something with hidden. We're finally starting to check hidden inside of here. But I feel like we might be a little too deep in there. I think we could have bailed earlier. Like for one thing, this entire group could be hidden. That we're the group that we're looping through could be hidden, in which case we don't need to bother looping the children because we know everything will be hidden. But then the other thing is maybe we could be checking outside of here instead of going inside. Let's look. So we go first draw hidden equals self-hidden or hidden by parent. If hidden, if not first draw, previous area next equals tail. Return self previous area, so that's like it's advancing or something, I think. Otherwise, if it is the first draw, then just return tail. Else, if it's not hidden, but it moved, and it's not the first draw. So it's not hidden, it's visible, and it moved, and it's not the first draw. Then area union, dirty area, size, U. I don't know what that's all about. Unsigned, I guess. Never seen a U like that. Dirty area next tail, doing some more stuff with the next thing. This area next. And we have checking on types. So we're saying if it's a bitmap type, if it's a shape type, if it's a palette type. Well, no, not if it's a palette type. This is getting the palette to do something with it. Partial change. So we go through and all that stuff. Okay. I wonder if these are not getting set properly. Anyway, I think I'm gonna start putting my comment in. Thanks for the stream. Hope you have a wonderful weekend. Get outside, listen to some music. Yeah, yep. Thank you. Appreciate it. That will be the plan for tomorrow. Fingers crossed for some good weather. We post our reproducer. For one thing, the reproducer right now is not in the exact right state. I think I'm not going to post the reproducer just yet. Did we want to link to that loop I found. That was in refresh display. Fresh display 344-ish. It's not going to be the exact same because I have a bunch of content. I have many comments though. Do I? Maybe. Oh, 340, not 440. Okay. That's a little. Oh, I want to delete this, then refresh this. Lines, we scroll down again. Okay. Double check we're not putting anything crazy here. Successfully recreated the issue, learned a bit about it, but do still need say I never use commas right. I'm like terminally never using commas correctly. I don't know why. It's supposed to be easy. Like, do you pause if you say it out loud? I know the rule. I try to do it in my head, and like literally, I still never do it correct. So I don't know. But still need to dig a bit further. Do not have an actual solution to propose yet. Few findings. The test. Line object makes it go much slower than rect object. I tested by changing the 150 loop to make rect instead of lines, and the display refreshes much faster in that case. Let's say even if I make the rects be 100 by 100, which is the size of the bitmap for the line. Diagonal line. Oh god. Fully horizontal or a fully vertical line allows the display to refresh much faster than the diagonal line, which makes sense because the diagonal line is the least efficient since it has to make the bitmap big enough to contain the full rectangle that encloses the diagonal line, and many pixels will be transparent, whereas with horizontal or vertical, the bitmap gets to be the exact size it needs to be in order to show. Show line without any parent pixels. The place where we are losing time seems to be inside of this loop. Usually we get iterations within this loop for things that are hidden. When the lines are hidden, we are still iterating through them once per each line in this loop and calling refresh area on them. Thinking that may be a logic bug somewhere, because I would think that we could skip them in the refresh loop if they are hidden. Trying to chase a bit further into get refresh areas, which is where they come from before it starts looping over them. I'll have to dig further another time. Gotta stop for now. Cool. Okay. All right. So I will head out for the evening now. Thank you everybody for watching. I hope everyone has a good rest of your evening tonight, as well as a good weekend, a long weekend if you are in the US and celebrating the national holiday. So for all the folks who do get to have a long weekend this week, I hope you all have a happy and good and fun long weekend. Like I said, I will not be back tomorrow morning at 10 a.m., but I do typically stream at that time, Saturdays at 10 a.m. So if you come back next week, 10 a.m. on Saturday, I should be around, and most of the Saturdays thereafter. So yeah, I think needing to iterate even when hidden is in case they move but remain hidden. That's a good thought. Yeah, but shouldn't we only refresh like when it gets shown again? Like if it moves, what do we need? Why do we need to do any calculation if it moves when it's hidden? If it moves while it's hidden, we're not showing it, so nothing changes at that point still. I don't know, that's an interesting thought. An interesting thought. Although I will say something seems to be smart enough to skip them sometimes, because like the rectangles here, when we did not have them hidden, these rectangles here, they got skipped in that loop because they're not moving, because they're not changing colors, because nothing is changing about them. They got skipped by that loop, which the lines... I guess the lines do when they're visible, but they don't when they're hidden. So that part's the same. When they are hidden, they do get looped. But yeah, I don't know. Because it skips those iterations when they're visible, I don't feel like it should need to be different when they're not visible. Like it knows if they changed, and in our case they didn't actually change. They haven't moved, they haven't changed colors. So it should be able to skip them the same way, whether or not they are hidden. And further, in my mind, I think it should be able to skip them altogether if they are hidden. But even if we take that out of the mix, even if we don't worry about skipping them when they're hidden, the fact of the matter is they're not moving and they're not changing colors. And with these ones, in that situation, when they don't move and they don't change colors, it is able to skip them somehow. It should skip them the same way, I think, when they are hidden, unless if there's something that I'm not considering somewhere in there. If it later unhides already rendered, doesn't seem efficient, but maybe it needs true. It doesn't seem efficient, but maybe a need, and then the next message is true. Not moving should be super fast. Yeah, that's my thought, is we should be able to use the same trick. Whatever the trick is that causes them to get skipped while they're visible, at a minimum, we should be able to do that same trick while they're hidden, because they aren't actually moving. So we should be getting the same benefit of that whole like not becoming dirty, basically. What if they're moving causes them to become visible? So that can't. I mean, with the hidden, that can't happen, because if you move it, moving it will never change this hidden property. Hidden is different than simply off the screen. You might think like you could hide something by moving it off the screen, like to negative X and Y values. And you can do that. If you move a thing to negative values, it will, render off the screen. It won't be visible, but in that case, it's different than the hidden property. It doesn't get drawn on the screen. And then if you move it back on the screen, it could become visible in that scenario. It could move itself back to the screen and then needs to be drawn again. But that is a different situation than the property hidden true or false. The property hidden does different logic that is different from just moving it off the screen. It's like a extra little flag in there that it checks. Yeah. Good thought, though. All right, I will wrap it up there. Thank you, everybody, for watching. Thanks, Mr. Goodbits, for bouncing off some ideas with me here in the chat. Appreciate that. And Steve as well over in the YouTube. Appreciate everybody who's watching, and I will see you all later. See ya.